drill pipe insulation in the internal diameter. And I think with this Drakon, it gives you that flexibility and gives you that capability of thermal insulation and mechanical properties and lubricity. In a project in New Mexico for a major developer, we provided that pipe, that insulation, and it really made a difference. Temperature drops of 50 degrees Fahrenheit or 10 degrees Celsius just by insulating the pipe. 1 degree Celsius that you can control will increase tremendously the reliability of the downhole tools and the downhole electronics. So just think about a higher temperature well of 220 degrees C. You're able to, insulate it, and you are able to, control the temperature. You will drop 50 degrees Fahrenheit, which is significant. And even if you go in higher temperatures, you got a proportional gain. So yeah, it's really exciting to be in this space.
Welcome to Geothermal Unleashed, where we will explore the cutting edge of geothermal energy. I'm Elizabeth Cambre from the Vallourec New Energies team, and I'm here to help educate and document geothermal's rise in the global energy transition. Today, I'm delighted to welcome Alexis Garcia, the Director of Geothermal, joining me today from NOV. So today we're going to talk about all of the technologies that NOV has in their portfolio for geothermal, and we're going to learn a little bit about Alexis and how he transitioned into the geothermal space. So with that, I want to start by getting things kicked off, Alexis, by asking you to give us a little bit about your background, your education, your career, and how you ultimately got involved in the geothermal industry.
Great. Thanks, Elizabeth, for having me here. I'm really excited to be in your podcast. I was looking forward to being here, and now it's happening, so I appreciate that. So I graduated in petroleum engineering in Bogota, Colombia, and my career has been spanning for about 30 years, mostly in downhole drilling technologies, but I've also been involved in operations, engineering, and also business development. I had the opportunity to work and lived outside Colombia. I left Colombia about 25 years ago, and I started working in Argentina, Bolivia, Brazil, and then in my last part of the career, which has been the most number of years, in the US. And I pivoted to geothermal about a couple of years ago. And the reason for it is that pretty much it checks all the boxes. It's carbon free, it's renewable, it's base load, and it's reliable. So with that, there are different applications that go from direct use to super hot rock. I mean, it's a wide range of applications that the industry can help with. And there's also a natural compatibility with oil and gas in the early stages of the value chain. It means that, say, like for upstream, there is direct compatibility with equipment and technology that could help or will help reduce costs for geothermal. And I think one interesting side of it is that the talent pool and the technology migration potential is really palpable, is really tangible from one industry to the other. So to me, it made a lot of sense to be able to translate all that I've learned in the oil and gas space over to geothermal because it makes sense.
I love that. And I like how you said that there's so much in geothermal. And I agree with that because it makes things very exciting, but you get to use your background that you've developed from the oil and gas industry. So it's a really nice fit and it's exciting. But I'm very curious, how do you like working in the geothermal sector versus oil and gas?
Yeah, at first I was a little bit cautious, but once I got into the geothermal world, it's something that is really powerful in the way that it's a tight community, but it's also an open community. So everybody wants to share ideas with you. Everybody's open to talk. Everybody's open to listen. And I think with that open attitude, it makes things easier, it makes conversations much easier, and you get to, I guess, bounce off ideas much easier, which will translate into immediate gains and immediate cost reduction. So I think if you talk to the direct use people, they will be open. If you talk to the super hot rock people, they will be open for solutions and conversations. And I like that openness, and that relationship type is what helps you really drive technology advancement.
I agree 100%. I have found that, my experience in oil and gas versus geothermal has been very similar because the geothermal industry they're so kind, they're so nice, they
Right.
want to help, and they're passionate.
That's
So
exactly right.
it's easy to get on that geothermal train. Okay, so you're global, so you get to look at projects around the globe, which I am fascinated by this. I'm very curious to hear, what are some of your favorite geothermal projects that you've worked on?
Yeah, if you allow me, I will describe a little bit what NOV is, what NOV does,
Sure.
and then I'll describe the projects that I'm basically involved with. So NOV is a leading independent equipment and technology provider to the global energy industry. Over the past few decades, the company has pioneered and refined key technologies to improve the economic viability of frontier resources, including unconventional and deep water oil and gas. More recently, by applying its deep expertise and technology, the company has helped advance the transition towards sustainable energy, including geothermal, of course. Right now, the company has two segments. One is called energy equipment, and the other one is called energy products and services. And both have offerings and technology for geothermal as well. Uh, Today, many of NOV's oil and gas products are used for drilling geothermal wells for power and temperature control or heating and cooling. NOV's top drives, BOPs, drill pipe inspection and coating, liner hangers, completion tools, drill bits, and full land rig packages have been a critical part of geothermal development. Further, with geothermal power generation's recently renowned traction or reservoir independent systems, as IDC call them now, NOV has developed new proprietary products that address many unique geothermal production worldwide. And with that, we have a really wide range of solutions for geothermal. And there's been a couple of projects that I'd really love to refer to because for once they're challenging in the way that the rock is drilled and the cost reductions that the end user in the case of the developers have been measuring. One of them is Utah Forge. So Utah Forge over the 5 well campaign, by partly use of our technologies, from well number 1 to well number 5, the ROP was quadrupled, and the bit longevity was at least doubled. That represented a really high efficiency and a significant cost reductions for Utah Forge, which later translated into Furbo-Scape, a project in Utah. And that learning, that experimentation led to even set up a good benchmark for Furbo to keep building on it. So that's a really exciting project to be, and hopefully that'll keep on continuing. The other one, which relates to that type of learning, is Switzerland. I was in Switzerland last year while drilling hot granite, just like the granite that you see in Utah Forge, but this was about 10% harder than the one in Utah Forge. We discovered that through some rock samples here that we analyzed in the laboratory with single PDC cutter test, and we kind of visualized that the rock was going to be more challenging to drill. So we made some iterations, mostly in the drill bit side, to be able to cut the rock and fail the rock a little bit more efficiently. With that, in just one well, we were able to say 23 days versus plan, which is excellent from the operator's perspective. And again, they just happen in just one well. So those are kind of my flagship couple of projects that I could refer to.
Okay, I didn't know that about Switzerland. That's very interesting. So this questions kind of goes along with the last one that I asked. When you are looking around the globe, what areas or countries most excite you when it comes to geothermal opportunities? And
Yeah,
maybe it's Switzerland.
yeah. Well, that's one of them. But Elizabeth, I think with this, we have to take into account where is the market situated right now in terms of installed capacity. If you look at the IGA figures, right now there are about 3 exajoules of installed capacity, out of which 2.5 are for heating and cooling, and around 0.4 for power. The projection is that it'll grow to 30, so tenfold by 2035 at roughly the same proportion. So if you extrapolate that, it means that the heating and cooling market is exploding, really, for geothermal. And one exciting area is Europe. I think Europe is going to be, and it is already, a leading growing market after China, right? For heating and cooling. And that's going to be, I think, really exciting to be in, because the technologies are going to be directed towards reducing cost and scalability. I think scalability is a big portion of it, and technology companies, service providers, equipment providers like NOV will play a critical role into providing the best equipment and technologies for cost reduction. So that's a really exciting one. So that's for heating and cooling. And also, I don't want to say that power is not that big. And I think power generation is going to be huge. And that's another really key market. Of course, we have this new generation of reservoir independent systems that go into hot rock, and that's going to be challenging. It is already, but we're making strides toward there. And also super hot rock. I think if you see that market expand a little bit on the super hot rock side, not only you will have better productivity and increase tenfold, 5 to tenfold, whatever you're seeing for a conventional geothermal well, but you'll see that expansion once the technical feasibility is overcome of higher temperatures, and also for well integrity, because that's a key component of that. Is you really have to take into account not only the drilling portion, right? It's the first part, but then well integrity. And I think that is something that the industry is a little bit wrong on it, and I have to really understand the implications of, you're not going to be producing steam for 1 or 2 years. You're going to be producing steam for 20 years, 25 years. What's going to happen with the well? And I think that's going to be a key thing for the industry to work towards too.
Right. And so there's a lot of technologies within NOV's portfolio that helps with the integrity and drilling. So let's turn now to talk about what NOV has in their portfolio for geothermal operations and wells. Let's start first with the ReedHycalog Phoenix drill bit. Can you walk us through this technology?
Sure. Going back to my previous example in Utah Forge, what we did with Phoenix bits is to follow a rigorous, meticulous design process to iterate in between wells. So that translated into a big portion of that big efficiency gain through increasing ROP 4 times and through increasing bit longevity by 2. So with that, we followed an engineering approach to design bits, and it translated into the gains. Of course, we coupled that with physics-based approach that Texas A&M had or still has to apply the best parameters to decrease mechanical specific energy while increasing depth of cut. That means that in a hot, dry granite, while you increase or your depth of cut, you indent better your PDC cutter, you will have better efficiency while cutting the granite, which is a little bit counterproductive to what we've been taught in the drill bit industry.
Okay, so did I hear you correct? You iterated on the drill bit between wells?
Yes.
Okay, that's quite an achievement. I mean, I've worked with technology, and making changes to technology quickly is always challenging. So, and how fast were the wells spaced to where you had to optimize?
They gave us enough time to iterate from well to well. Of course, there are some wells that in general the spacing could be a little bit faster, but engineering iterations could be small tweaks to the bit design that will translate into higher ROP and longevity, or it could be a little bit deeper type of changes. In this case, what we did was we reformulated the PDC grade and the bit body configuration to be able to have a better efficiency and better rock destruction mechanism in the granite to make it happen.
So did you have this, was this a strategy that was put in place before they started drilling the wells, that you would actually be optimizing the drill bit between the wells? Or was it just after the fact? You got the results on the ROP and then you said, okay, let's see what else we could do.
No, we did that while the well was being drilled, basically. And by the time it reached TD, we went back to the drawing board and said, well, let's go ahead and redesign these particular part numbers. And that's what we did, basically, to increase. So the one big portion of that is we started replacement roller cone bits by PDC bits. It's a simple strategy. But then you have to iterate the PDC bit in such a way that it'll give you more ROP, or rate of penetration. And more longevity. So you have less trips for bit replacements, basically. So that's what we discovered we needed to do, is reformulate and the PDC grades and reiterate the design aspect of the bit body, and that's what we did. So that teamed up, or that was mixed with the physics-based approach that led us to this revolutionary change and increase in efficiencies.
I love this story. That's a great story. Okay, there's a lot more technology, so let's move to the next one. We now have the Daytona drilling motors. So why are these a good fit for geothermal?
So in geothermal, of course, you need a very efficient drill bit, but you also need some power that backs it up, and some drive that backs the bit up and gives power to the bit. One of them is the motors. So NOV's got really good experience in geothermal wells worldwide, and these particular motors, could be high torque, but they're mostly even rubber thickness motors, which really provide more torque, more power to the bit. In geothermal wells, they've been widely used, as I said, and they've been helping reduce the drilling cost. In different operators or in different end users. Right now, again, going back to the European market, we're working with a major developer in Germany that is using these motors, and we're working in Iceland as well, and different parts of the world where you see higher temperatures. So it's a very interesting technology, and it's evolving as well, and we're really excited about the motors.
Okay, that's another great technology. Let's now talk about the PosiTrack TVM. What is this?
TVM is torsional vibration mitigation. It's basically a tool that you place within the BHA, or bottom hole assembly, to control torsional oscillations in the form of stick slip or just torsional oscillations. Normally, when you drill a well, since your BHA is extremely long, right, from surface to the bottom, either the bit or the BHA, or combination between the two, will be prone to torsional or lateral vibrations. A combination of those. If you run into torsional vibrations, you get less longevity for both the drill bit and BHA components, which tend to be really expensive in the BHA. So by controlling or mitigating those torsional vibrations, you will, almost guarantee better longevity for the downhole tools, including the drill bit, which translates into less trips for bits, less trips for BHAs. When something's damaged because of vibration, either electronics or mechanical failure, or twist offs, or something that derives directly from stick slip, then you will be able to save a lot of money with the use of that tool.
So is this a staple technology that would be used on every oil and gas well?
Well, I guess to answer your question, should be used in every oil and gas well. It's not defined to be in every oil and gas well, but it definitely helps. One thing is to be able to know the placement of the tool and knowing what the tool does beforehand, so you're able to project and plan ahead where you're going to put it and what type of vibrations you're going to be controlling. And I think that's going to be really key for that. Once we have into that planning stage, we can know exactly where it's going to be working, how much it's going to be mitigating, and so on and so forth. So it takes a bit of planning, but it takes a lot of conversation with the end user and with the directional company, but we have a good history and good background to do that and to make that happen. And it takes trust, it takes conversation, it takes planning, it takes analysis, and you know that minimizes the risk. And then we started just quantifying the savings in drilling.
Interesting. Okay, and it's currently being used on geothermal projects?
Yes, yes, it is currently used. It could be used more. One of the things in geothermal is, the concern of higher temperatures, right?
Huh?
Um, of course, you have to control the temperature in a well, right? To be able to, extend longevity for the tool. So by controlling the temperature, I mean you have to cool the mud or chill the mud. You have to coat the pipe. I'm going to be referring to that a little bit later on to be able to, lower the temperatures in the well. Um, with that, it's almost like an oil and gas well in temperature. So it's not like it's going to be exceeding the temperature. Now, one important fact is that you have to circulate continuously, because if you don't circulate continuously, then you'll be able to let the heat build up within the drill string, and you want to do that because then you'll start getting into the threshold of the temperature ratings of every tool. So if you cool the well by continuously circulating and by having coatings and mud chitters, you'll almost guarantee to drop the temperatures to an oil and gas type of temperature range.
Now let's turn to talk about the Tuboscope TK-Drakon coating. How necessary is this coating for geothermal applications, and how has it been used?
Sure. So the Drakon coating is the latest release of coatings from Tuboscope, and it's an internal insulating coating. So what this is it deals with thermal conductivity. Thermal conductivity of a material is a measure of its ability to conduct heat. The heat transfer occurs at a lower rate in materials of low thermal conductivity than in materials of high thermal conductivity. So, for example, if you talk about diamond has a thermal conductivity of 1,000 watts per meter Kelvin. If you compare it to copper, it's got 400. If you compare it to aluminum, it's got 237. Carbon steel, it's got 45. Water has 0.5918. Polyurethane foam has 0.03, and then the Drakon coating has 0.1620. So you kind of visualize the range of thermal conductivity ranges and the K value or the K factor, and not only that aids with the thermal isolation or the thermal insulation of the drill string, but it also helps with erosion. It also helps with mechanical properties if you're pumping, high solids within the mud, and it also helps with lubricity. So it's got significant side effects to the drilling operation. So it's really interesting to see the evolution of those coatings and see how much they really insulate the temperature. And I was kind of thinking about VIT. How do we coat VIT so we increase further the efficiency gain with that, right? That's an idea that is out there.
Okay, so there's so many benefits. So you've got the thermal insulation, erosion. I have heard from some customers this challenge of erosion in geothermal casing. And then you've got, you said lubricity, so friction.
Right.
Corrosion.
Yeah.
So why isn't this more widely, drill pipe it's needed, but why isn't it more widely used as like a standard staple coating for geothermal? Should it be?
I think it should be standardized all throughout, because, again, even if you don't have a super hot rock well, you'll still need those capabilities for lubricity and for erosion and mechanical resistance. It's something that it's been used mostly in oil and gas wells in the Haynesville, where the high pressure, high temperature is there, and there are many papers written on it. But I think as we progress on the drilling side in geothermal, I think that should be spec'd out as far as drill pipe insulation in the internal diameter. And I think with this Drakon, it gives you that flexibility and gives you that capability of thermal insulation and mechanical properties and lubricity.
Okay, I have a question. So is the NOV drill pipe that has this Drakon coating, is that widely used now in the geothermal space?
I think it's got its niche right now, but it should grow as we grow the geothermal industry. It's been known and widely used by reservoir independent end users, but it should expand its use as we grow the geothermal industry in the next generation project. So I think the market is there to expand the coatings, and I think there's no downside. I mean, it doesn't flake off, or the possibility for it to flake off is minimum. If you operate it within the recommended parameters. So really there's no downside of it. So the only way is just to expand that and to be able to show and prove the technology that it works and that it insulates the temperature and it aids with the drilling process.
I was once talking with someone from the Department of Energy, and I asked them, what is the most exciting technology that you've seen come out in geothermal? And they said NOV's insulated drill pipes. So
Yeah,
yeah.
and it actually is exciting, and it actually helps. In a project in New Mexico, for a major developer, we provided that pipe, that insulation, and it really made a difference. Really made a difference, and it still does. So, you could have temperature drops of 50 degrees Fahrenheit or 10 degrees Celsius just by insulating the pipe. 1 degree Celsius that you can control will increase tremendously the reliability of the downhole tools and the downhole electronics. So just think about a higher temperature well of 220 degrees C. You're able to insulate it, and you are able to control the temperature. You will drop 50 degrees Fahrenheit, which is significant. And even if you go in higher temperatures, you'll get a proportional gain. So yeah, it's really exciting to be in this space.
Very cool. Okay, so let's turn now to the Tundra Max Mud Chiller. Can you talk about this technology for geothermal?
Sure. So if you connect, the coating or the insulative coating of the pipe, if you continuously circulate within your drilling operation, then you have to cool the mud, right? You have to chill the mud, and by that you'll guarantee much lower temperature exiting out the bit. And what the Tundra Max Mud Chiller does is it is basically a cooling, done via refrigeration system. It's almost like a fridge in your home. It's got the ability to precisely control the temperature, and it's really effective in high ambient temperature. So if you're in a really hot place, it's very effective, cooling the temperature of the mud there. The other characteristic or the other benefit is that no water source is required because it's closed loop water loop that works in both water-based muds and oil-based muds, and it's a two-stage cooling system. The first one is an air blast plate and frame heat exchanger, and the second one is chilled water plate and frame exchanger, which basically translate into the same effect as you would see in your fridge in your home. And that translates into a 20 to 30% temperature reduction in the mud, which is significant for what you need in a geothermal well. So it's something that, again, is not used in every geothermal well. I think it should in higher temperatures, but it's a technology that is really exciting. And again, it's been migrated from the oil and gas industry in high HPHT or high pressure, high temperature applications to geothermal. So that's another obvious technology that should be, standardized within geothermal.
Okay. One of the last technologies that you're going to touch on, I actually got to see. So earlier this year, we did the closed loop geothermal symposium at the Navasota facility, NOV's Navasota facility, and it was Chuck. He showed me the Cellar tech well containment for geothermal, and he pointed it out, and I thought that was kind of neat. Can you walk us through this technology?
Sure, I remember that day, Elizabeth. It was rainy, cold, gray, but we all went out and took a look at the rig and the Cellar tech. So Cellar tech is a very exciting technology. It is basically below grade. It's secure. And it's got an easy access for safety purposes as well, and it's OSHA compliant. And it's also inconspicuous, right? Because you don't really see it. It's tree friendly, and it's you can use it for pad drilling. One of the benefits is that you have controls integration. It talks to the HMI data and acquisition system. So you have different benefits by using it. So if you say, for example, if you go to pad drilling, you have different wells in there. You can put them all below grade, and even though you can even redesign the Christmas tree to be put horizontally, for example, or vertical, however you want to do it. So it's going to be below grade, and it's got a lot of benefits. We're working with some end users to be able to implement that for different projects, including projects where there's going to be many wells drilled, and that's going to be making a lot of sense because you don't see anything in the surface, right? That's what we call it tree friendly. So it's a very exciting technology. Again, being migrated from oil and gas, and right now being applied in geothermal. But those are kind of most active technologies that are going into geothermal. But we have fiberglass systems. Fiberglass systems is a really exciting technology as well, for corrosion, for mitigation of temperature, things like that. A lot of benefits. Same thing with completion tools, and of course the rigs.
I'm always impressed with the vast scope of technology that NOV has in its portfolio. And one of the final questions that I just want to ask, when you look at all the challenges, are there technologies that NOV is working on that you don't already have that would solve a key challenge in geothermal?
We are working on some, but I'm not allowed to talk those developments for now. But yes, we're working on some of the things. What I can tell you, Elizabeth, is that first you need to understand the pain point and understand the need. Then you come up with the solution to be able to kind of mitigate that or solve that in a way, and then you start iterating. So if we don't understand the need, and if we don't understand the actual pain point, we're not going to be able to formulate the right solution. So yes, we're working on a really exciting couple of projects, and I guess we'll see them in the market in the near future.
I can only imagine that they're very exciting. Well, Alexis, I want to thank you for joining myself and the listeners on this episode of Geothermal Unleashed. And I do hope that today's discussion has sparked new interest and deepened everyone's understanding of the geothermal industry's incredible potential. Until next time, keep pushing the boundaries of what's possible, and let's continue working together to unleash the full potential of geothermal. Thank you.
Thanks, Elizabeth.